Hi everyone, my name is Rishikesh Palve. I'm part of product management team in containers and Kubernetes services at Oracle Cloud Infrastructure. Welcome to this learning session on how to get production ready applications in less than 30 minutes with serverless functions. Let's begin with a quick overview of Oracle Functions. It is a fully managed, multi-tenant, and highly scalable functions as a service in Oracle Cloud Infrastructure. It is built on the next generation Oracle Cloud Infrastructure and seamlessly integrates with other OCI services to provide a comprehensive platform. It is based on the open source FN project, which is a container native functions as a service platform that packages your functions as containers and runs them anywhere in any cloud or on premises. It is designed with security built in. It provides strong isolation, fine grained access control, and features such as secure networking, image signing, and scanning. The three key tenets of Oracle Functions are it is an autonomous service. The platform automatically scales based on the concurrent invocations for your functions. This means you don't have to provision any servers and manage them for deploying, running, and scaling your applications. The second key aspect is you only pay for the execution time of your functions. You do not have to pay for the idle time. And Functions is designed as an event-driven platform built into Oracle Cloud Infrastructure as it provides built-in triggers across various OCI services. On the next slide, let's understand how Functions is an OCI native event-driven serverless platform. A developer writes functions code and deploys it using CI/CD on OCI. Once a function is deployed, it can be configured to be triggered by one or more triggers. These could be OCI services such as events, notifications, API gateway, service connectors with logs and streams as source, or a function can also be invoked using the function invoke endpoint through CLI, SDK, or through HTTP. When a function is invoked, the function image is run as container and function executes inside that container. As the function is executing, it can access other OCI resources and services such as object storage, database as a service, including autonomous database, data warehouse, and NoSQL database. It can also access resources and perform operations on those resources such as vault, compute, networking, and so on. Functions also provides end-to-end visibility by providing built-in logging, metrics, and distributed tracing. This is how it provides a complete platform, and that's why it is a popular choice among our customers to implement various use cases using functions and combining it with other OCI services. Some of the popular use cases for functions are building event-driven applications, as well as event-driven workflows for performing various operational tasks, including governance and administration. Customers also use functions along with API gateway and other OCI services to build scalable web and mobile API backends. It is also a good fit for real-time data processing use cases, including file and stream processing. And it is also useful for building modern cloud-native applications that are powered by AI, machine learning, and DevOps. With that quick introduction to functions, now let's understand how you can build applications using functions. So let's begin by understanding basic concepts of functions. First concept is called as an application. In functions, an application is a logical grouping of functions. It is a way for you to ensure that functions are isolated at runtime. An application is attached to a subnet in your VCN. The next concept is functions. Functions are small blocks of code that generally do one thing very well. They are packaged and stored as container images. Then the next concept is invocations. When a function is invoked by sending a request or by sending an event, function's code is executed inside a container. And that's how a function invocation works. And finally, a trigger is an action that happens elsewhere in the system. It could be within OCI or external to OCI, which invokes a function to perform a particular operation. The function can be invoked using CLI, SDK, HTTP, or using other OCI services. Now let's understand how you can develop functions in OCI and what the developer experience looks like. In functions, we provide built-in support for code editor, which is a rich in-console editor that provides built-in Git integration for version control. It has built-in plugin for functions that automatically sets up the development environment for you so that you can start developing functions right away without having to install and set up any tooling. It provides features such as autosave, and it persists state across multiple user sessions. If you want, you can also set up the development environment yourself, either using OCI Cloud Shell, which is a command line interface in OCI, or you can choose to set it up on your local machine or on an OCI compute instance. Functions also provides native support for various languages and frameworks through function development kits. These function development kits provide support for popular languages such as Java, Node.js, Go, Python, Ruby, and C Sharp. But that does not mean you can build your applications only using these programming languages. You can choose to develop your application using any programming language and use the bring your own Docker file support in functions to provide a custom Docker file to run your application as a function in OCI. It also provides native Graal VM support to help you build cloud native high performance applications using Graal VM. Once a function is developed, it can be deployed in OCI using a single CLI command called fndeploy. This command performs all the deployment operations, including building the code, packaging it into an image, pushing that to a registry, and then deploying it as a function in OCI. You can also leverage the native integration with OCI DevOps to set up continuous integration and continuous deployment pipelines. You can also choose to set up your own DevOps tooling for CI/CD. OCI DevOps service provides managed build and deployment pipelines with native support for deploying functions. Functions also provide Terraform support so that you can use it for writing infrastructure as code and leveraging that for automated provisioning of resources using the OCI Resource Manager service. Now, coming to the configuration, it is recommended that you should externalize the configuration instead of hard coding that into your function code. And that's why we provide first-class support for configuration. You can define it at application level or function level. Configuration defined at application level is inherited by functions within that application. You can also leverage the seamless integration with OCI vaults to store the secrets securely. Functions also seamlessly integrates with the OCI container registry to provide built-in image scanning for scanning security vulnerabilities. And you can also configure it to enforce use of signed images only when functions are getting created or updated. Now, once your applications are deployed, it's important that the application meets your organization's standards in terms of performance and security, and it provides you full visibility into the execution of that application so that you can ensure reliable operations. Function provides built-in security, as I mentioned earlier. It provides execution isolation using applications. So functions from different applications are completely isolated from each other. all the egress of functions is via the VCN that's connected to your application, so you have full control over the networking configuration. Functions provide built-in access control. You can leverage OCI identity and access management to set up role-based policies to access and invoke functions. You can also use functions resource principle to configure fine-grained access control using policies to allow a function to access OCI resources and services. In terms of compliance, functions service is available in all OCI public commercial regions, as well as in government and high security regions. It means it complies with broad set of compliance standards, including ISO, SOC 123, HIPAA, and many more. Now, coming to the performance aspect of functions. Functions is a fully managed service with its control plane and data plane components distributed across multiple availability domains to ensure resiliency and high availability. When a function is invoked for the first time, it pulls the image from the container registry and runs the function image as a container. This initial provisioning of a function execution environment could take some time. So in case if you have use cases that require sub-second latency and you want to avoid such cold starts, you can leverage the provision concurrency feature of functions that allows you to minimize the initial provisioning latency for your function and ensure minimum number of concurrent invocations. And as I mentioned earlier, function provides built-in support for logging, monitoring, and distributed tracing to give you full visibility into the application. And now we are excited to announce a new capability called as pre-built functions as part of the functions service. This capability will be available soon within the functions service, and it will significantly simplify how you can use functions to enable various use cases that we discussed earlier. Pre-built functions provides a catalog of ready-to-use functions that you can easily discover in console or using API. It provides one-click deployment experience, and you do not have to write any code or maintain that code. Oracle provides a set of pre-built functions for performing common tasks and actions across various OCI services. And these common tasks and actions will enable you to implement various use cases end-to-end across functions and other OCI services. Some of the examples of these use cases are security and observability. For example, integrating with third-party solutions or automating security remediations. Other good examples are cost management, governance, and implementing event-driven workflows. Now, with that overview of functions and the new capability called pre-built functions, let's see how you can leverage functions for developing production-ready applications. For the demo, I'm going to use a real use case where passengers can track their baggage information in real time using the mobile application. For this, we have set up a fictional entity called as Blue Mist Airways that focuses on the passenger experience and provides a mobile application where passengers can track the exact location of their baggage in the application. This application is powered by Oracle functions and other OCI services that are available in a serverless way. So as part of functions, we have a query function that fetches the data from the NoSQL database and exposes it over API that is consumed by the mobile application. And the baggage information itself is streamed from the operational database into the NoSQL database using the OCI streaming service that invokes the function that updates the data into NoSQL database. Now let's see this live in action. Let me switch to my browser and show that to you. In my browser, I have opened the mobile application. Let me go ahead and click on track your baggage. As you can see, I can see the exact location of the baggage. Now let's see how this application works at the backend. I have already logged into OCI console and navigated to functions. Here I have already created a baggage tracking application, but let me show you how easily you can create a new application. First, we'll start with creating an application. As I mentioned earlier, application is a logical grouping of functions. While creating function, you need to specify while creating the application, you need to specify its name, select the virtual cloud network, and also select the subnets. Functions will execute in the subnet that you selected. Then you can go ahead and create the application or save it as Terraform configuration to use Resource Manager. Since I've already created the application, let me go ahead and open it. As you can see, inside this application, we have two functions deployed. First function is baggage info load. This function streams data from the operational database and inserts that data into the NoSQL database using streaming and service connector hub. The second function is called baggage info query. This function fetches the data from the NoSQL database and exposes it over an API endpoint. As you can see, we have already configured the configuration parameters to access the NoSQL database. And if you want, you can also enable the signature verification to enforce image signing. Now, let me go ahead and show you how you can create a function using the built-in code editor support. Once you click on Create in Code Editor, this will launch the code editor in the console itself. So I have already launched the code editor, and here in the code editor, using the function plugin, you can see all the compartments in the tenancy, and within the specific compartment, you can see the function application, and you can also see the functions that are deployed. Now let me go ahead and click on Create Function option. This provides three options to create a function. This helps you get started quickly. You can create from a template, or you can choose to create from a sample. We provide a number of samples in our repository. Or if you already have a function created and check the function code into a code repository, you can select Create from a code repository option. Let me go ahead and select Create from a template option, and I'm going to use Python as the language. Now, next thing I need to do is provide the function name. I'll keep the default name, and that's it. This is going to generate the function and the boilerplate code for that function. As you can see, it has created these three files. Let me go ahead and open this file, func.py. This has the boilerplate Python code to implement the function. It has the handler that receives the request or the event, and you can then implement the business logic to process that event. This is a simple Hello World application. Along with the Python code, it also generated func.yaml file, which has the metadata about the function. This includes name, version, runtime, and other parameters. Since this is a Python code, it has also generated a requirements.txt file for the dependencies. And here you can see it is using the function development kit. Now let me switch to the edit view and open the code that I have already deployed. First, let me open the baggage info query function. This is implemented using Node.js. So let me go ahead and open the code. This particular function, it queries the data from the NoSQL database. So it uses this endpoint called as getBagInfo by ticket number, which executes a query on the NoSQL database. So you can see this particular endpoint, when it is invoked, it executes the query on NoSQL database and returns the response. And in the code, we can also see it has created a client for the NoSQL database to connect to it. Now let me open the YAML file for this function. Here you can see the metadata about it. One thing to note here is for the runtime, instead of Node.js, I have specified Docker. This is the bring your own Docker file model that I was talking about earlier, which allows you to customize the runtime environment and use your choice of programming language. For that, you need to provide a Docker file. So this is the Docker file that I have provided. Now, let me go to the other function, fn baggage info load. This function is implemented in Python, and this function puts data into the NoSQL table called demo. Let me also scroll down. And one thing I want to highlight here is this is using resource principle. This resource principle is used to configure the IAM policy and control access to the NoSQL database from the function code. As you can see, this code also uses the configuration parameters that we have defined to access the NoSQL database. Let me quickly open the YAML file for this function. Here, if you can see, it is using Python as the runtime. So it is using the native language support instead of the bring your own Docker file option. Once you have developed your application, you can run a single command on the command line to build the code, package it, and deploy it. So the command for that is fn deploy application name and then the func name. So as soon as you run this command, it will build, package the code, and deploy it on functions. Since I've already deployed this, I'll skip this step and go back to the functions tab. So here, this baggage info query function, it is deployed in this particular application, and it is deployed in the private subnet. So in order to expose this as an API, we are going to leverage the API gateway service. For that, I'll go to the API gateway service. I have already deployed, I have already created an API gateway here and deployed the API configuration to expose the function as an API backend. So in the deployment, I have already created this deployment. Let me quickly show how you can configure the deployment. So you can provide the basic information, and you can also leverage the built-in API request policies to enforce policies such as mutual TLS, rate limiting, usage plans, and so on. Then you can configure authentication for the API. You can choose to configure the authentication with single provider or multiple providers. After that, you need to configure the API routes. So you can specify the path, select the HTTP method, and then select the backend type. This is where you can leverage the seamless integration with functions. So I've selected Oracle functions as the backend type, and then all you need to do is just select the function that you want to use at the backend. So I've already selected the baggage info query function. This is how you can create the API gateway configuration and deploy it and access the function through the API gateway. This has already created the API endpoint. I've copied this in the next tab, and using the API endpoint, we can now access the function. So as soon as we hit the API endpoint, it gets the data from the NoSQL database, and we can also use ticket number as the query parameter to get specific records. So this is how you can query the API. Now let's see how you can stream the data in real time using functions, streaming, and service connector. So for that, I have created this service connector, which uses streaming as the source and function as the target. And I've selected the baggage info load function as the target for this. it uses baggage info stream as the source. So let's open the stream and let me quickly produce a test message to simulate the baggage info data. Let me copy the test data and paste it here. And let me also copy the ticket number. Before that, let me quickly show you the table in NoSQL database. As you can see, right now we have 8 records here. Let me go ahead and produce the test message and copy the ticket number again. This should invoke the function, and that function should put the record in the database. So now if I go back and run the query again, I should see more records. Okay, now we are seeing one more record being added. If I hit the API endpoint again, I should be able to query the new record. So as you can see, I'm able to query the new record. So this is how you can use functions and other OCI services to implement end-to-end real production-ready applications without managing any infrastructure. Before I conclude the demo, let me quickly show you how you can also automate the provisioning of infrastructure resources. So I have created the DevOps project and created a repository where the infrastructure as code configuration is generated using Terraform. And using OCI Resource Manager service, I have created a stack and applied that stack to automatically provision the resources. I have also set up the DevOps project to use the native function support to create deployment pipeline for automatically deploying the functions using continuous deployment. So this concludes the demo. Let me now switch back to the presentation. So this is how you can leverage the strengths and benefits of Oracle Function Service and use it along with other OCI services to build production-ready serverless applications and run them at scale without managing any infrastructure. Hope this was useful. Thank you for joining the session and hope you have a great event. Thank you.